Hello guys, in previous episode, we have learned how to create a new project for STM32. The name of the project is Blink LED, but actually we were not able to blink the LED because we just compile the project successfully. It's very simple, just create a new project. So for this episode, we are going to blink the LEDs. So let's get started. So the topic of this project is light the LEDs. Create the first project. We are going to manually port the STM32 H5 HAL to Keil MDKs. We will take the LED blink as an example. The prerequisite for the new project, just like we need to download the STM32 H5 cube library. It's a type of zip. And we also need to install the Keil MDK with ARM compiler. It's already installed in the last episode. For the hardware, we need to STM32 H5 board. As the last project, we will use the Nucleo H563ZI. So the key files to cherry pick for the new project include core files, user files. For core files, we will copy the driver HTML32 H5XX underscore HAL underscore driver, include and source files. It includes the HAL, GPIO, RCC, call text, etc. And also we need to CMSI device ST STM32 H5XX, include the startup, assembly language, linker script, and system files. The linker script is optional, so you can use the predefined linker script or use the linker script provided by the ST. And also we need to include files just like the CMSI header files. It's for core ARM headers. We also need to user files just like the custom main.c STM32 underscore HAL conf.h and STM32 H5XX underscore it.c. it abbreviations for interrupt. So it's the interrupt handler for all kinds of the interrupt. Okay. This picture manifests the required files copied from the drivers. So before we copy the driver files, we need to download the HTML32 cube library because the drivers and the HAL library is included in the STM32 H5 cube library. So let's go to download the STM32 cube library. Okay, let's search the keyword HTML32 cube H5. So the first one is where desired. Let's click the Get Software and click the Get Latest. Let's click Accept. I'm able to download the STM32 Cube H5 v 1.5.0 directly because I have already logged in my account. For you, if you not sign in your account, you need to sign in your account firstly. If you don't have the account, you need to register one for free. Okay, I have downloaded the HTML32 Cube H5 v 1-5-0. So I just cancel download. Okay, Let's open the downloaded file from the folder. So you need to extract all files included in the zip file. Then there is a new folder extracted, which name is HTM32 cube underscore firmware underscore h5 underscore v 1.5.0. Okay. For the drivers folder, is crucial for us. So we need this folder, and we will copy the required files from drivers. Okay. You can see the manifest. The first column is driver. So driver is where we are desired. So let's copy the driver outside of the folder. I already copied one, so I need to delete it firstly. Copy and paste. Okay, we can compare the folder structures with the manifest. So there are two folders under driver, CMSIS and HTM32 H5XX underscore how underscore driver. So the BSP, we don't need it, just delete. And for CMSI, there's two folders and CMSI, device and include. So we just keep the device and include, select all, exclude device, include, and just click delete. So wait for a moment. There are so many files. Okay, it's a little bit slow. Please be patient. Okay. Okay, just device and include left. So go deeper. STE, STM32, H5XX. Okay, include and source. So select one, select all, exclude, include, and source. Click the delete button. Okay, so let's enter the INC folder and compare with the manifest one by one. So we select all, and we will cherry pick the header files we need. So the first one, legacy, we needed, and how.h we needed, conf underscore template we needed, context we needed, definition we needed, and flash we needed, GPIO and GPIO extensions we needed, power we needed, power extensions we also needed, and RCC we needed, RCC extensions. So others we can just delete them. Okay. So we copy the conf underscore template and paste, rename the header file, just remove the template and the hyphen copy. So name it to HTM32 H5XX underscore how underscore conf. So let's go back to parent folder and enter into SRC source. So we compare the manifest with the folder one by one, how we need it, context we need it, flash we need it, flash extension we need it, and GPIO, and power, and power extensions, RCC extensions. So that's all. Then delete others. Okay. That's all for the header file and the source file. Extract from the driver and copy. Then the left source file and header files and other just like assembly language files just left it there. Okay. So I'm going to create a new project. Okay. Let's name the project. I'm going to create a new folder. You can use the project we have created in the last episode. So here, I'm going to create a new one. Okay? Name of the project, Blink LEDs. Okay? Just copy the driver from the cherry-picked folder. Copy, go back, then create a new folder named source. So I'm going to put all kinds of the source file here. So I'm going to create a new folder named users. So as a subfolder, application. Okay, let's go back to the Blink LEDs folder. So I'm going to create new folder, new project here. The project name also Blink LEDs. Let's save the project. Okay, let's search the chip name STM32 H5 ZI63 ZITX. So click OK. You can just click cancel. So here we don't use the library provided by the PAX installer. So just click cancel. Okay. You can click the target to rename the target, or you can just click the icons here to name the target. I'm going to rename the target to STM32 H563 ZITX. For the source group, it will group the source files in different folder. Actually, it's the group. So you can just name the group with the folder path. So I'm going to add new groups with the folder structure here. I'm going to a new one, but we typically need to add the groups with the name. So let's open the notepad. So paste here, just click Control plus H, so to replace the slash. So I'm going to paste here is the group name. So you can find the corresponding folders with the group name. Also, I'm going to add a new one like this. Just add a subfolder arms. So I'm going to add a new one. Let's go back to the root folder. So I'm going to create new groups named users application. Okay. So for the first group, I'm going to add new files, just a copy from the drivers. Okay. Let's click source drivers, CMSI device, STM32H5XX source template. Then add the STM32 underscore STM32H5XX.c. Just click add. Please be note that when you click the add once, it's already added to the files list. So don't add twice. Just like I click the add, there is a duplicate entries in the files list. So don't do that. So I'm going to delete. And for the ARM, we are going to add new files. Device, ST, STM32H5XX source templates ARM. Oh, it's invisible by default for the .s files. .s files is an assembly language files. So just click assembly source or just all files. So it will be invisible to us. The name of the assembly language files is startup underscore STM32H563XX.s. So just click add. Okay, it's added to the file list. For the user / applications, we just leave it there. So I'm going to click OK. You can see here the edited files will be associated with the project and tag it. Okay, let's configure the options for target. So the first, the device, we already choose the STM32H563 ZITX, so leave it there. It cannot be changed here. Target, leave it there, and the output, you can click create a hex files. For the output folder, by default, there is a object folder will be created, but I don't like the structure of the folder and the files. So I'm going to create a new project because it's easy to organize. So the name of the folder is compilations. I like this name. So I'm going to create a new folder object and create a new one listings for the next tab. Okay. So I just choose object, then OK. So the create executable will be copied to compilations/object blink LEDs. So the next tab is listing. So just like the actions we did, select the folder for listings. So go back. So let's click compilations and the listings. Just click OK. That's fine. Okay. For the users, leave it there. C and C++ AC6. We need to add some directives. It's not a directive, it's just it's type of the macro. So we need to define the macro here. By the way, we enter definitions here. It's very similar to sharp to define macro like here, like this, just AA, but it will be visible to whole project. If you define the macro inside a .c files, it's just visible to the .c file. So here we define the macro globally. Okay, STM32 H563. Okay, XX. Use how driver. Okay, then click split loader and store multiple, or just leave it by default. Leave it default. Let's select AC5 hyphen like warnings. Okay. Let's include some paths for the header files. Okay. For the first one, before we select the include, we need to add new groups. Let's go back to the root of the folder. Drivers, STM32 H drivers, STM32 H5XX underscore how underscore drivers. So we need to add new groups for how library. So let's open the notepad and replace, copy the path and add new. Okay, you can place the group in a new positions. Okay, let's add new files. Drivers, how library, srcs. So just Control plus A to select or to add. Okay. Then click OK. So the how drivers will be associated with the project. Then we open the options for text again. So just go to the C and C++ AC6 directly, and then include the path again. So the first one, we need to include drivers CMSI include. Next one, source driver include select folder. And then go to source, drivers, how, make sure there's no include left. So drivers, administrative how drivers include. Include and the legacy. Okay. Then we also need to add a new folder under applications. The name of the folder, the first one is include. The next one is source. So we are going to include the application, but here we just add users. That's okay, because we add relative include. So just click OK. Then let's go to debug. So we select st-link debug. Then click reset and run. Because I didn't plug in the st-link, the nuclear board, so the debug adapter is invisible. So, but no worries, just click OK. Then OK. Here we add new items to the group user applications. Just name it main. OK. By the way, we also need the files HTML32 how conf. But anyway, we add a new math functions into the main.c with the void parameters. It endless while, then return 0. Then we just click rebuild or build to build the whole project to see what's the error left. Okay, there are a couple of errors, so we fixed one by one. So the first one, HTML32 how I catch not found. By default, the conf enabled the I cache. So we are going to disable that. So let's open the main.c, then right click the mouse, open containing folder. Okay. By the way, we can now delete the listing and object from the folder. So let's open source drivers, how drivers in inc, then conf. Okay. Edit in Notepad or just move it to the Keil window. Do you still remember there are some examples provided by ST? We just copied the STM32 H5XX underscore how underscore conf.h from the STM32 cube FW H5 folder. So let's go to the project and H63563 examples and GPIO and IO toggle. Let's go to the INC. Okay, this one. Just copy these files and open containing files. Just paste here. Replace. Replace. Okay. Yes to all. You can see here, by default, most of the modules not enabled. Just leave the iCatch module GPIO EXI, so we don't need the iCatch coming out. GPIO leave there, enable, because we are going to blink the LED is operated by the GPIO. So EXTI coming out, DMA coming out, RCC leave it there, power. Okay, then rebuild. Okay, flash extension is missing, so let's go and copy the flash extensions from the cube library. Driver, flash extension, open containing files, folders, paste. Okay, rebuild. Nice, no error left. So there is another .c files STM32 H5XX underscore IT.c. You can copy these files from the official examples. Sorry, not this one. Driver, project, example, GPIO, SRC, this one. Move it to the folder, to the Keil. Okay. Anyway, let's open the continuing folder from main.c. Then copy. By the way, I made a mistake. I create the main.c in the root folder, but we need to move it to the source users application source. Okay, no, remove existing files, source users application main. Okay, let's open. So let's add another one. So we are going to copy the STM32 H5XX underscore it.c into the in parallel with the main.c. Then add this .c into the group of the user application. Then compile again. Okay, because we copied it, but we don't need it. Okay, just remove the include. Let's check the system tick. Okay. We need to include the STM32 H5XX. Then we rebuild the project. Okay, fine. Let's go to my repositories on GitHub. GitHub tutorials. Let's click the link, applications, src, open the this.c, miscellaneous. Just click download raw file. Okay, let's place the files in our project in parallel with the main.c. Okay, source. Then we are going to include the edited file miscellaneously. Okay, add. Let's download another files from the GitHub. Go to the applications, ink, miscellaneously. Okay, download. Let's place the header files users application include save. Okay, then let's build again. No errors. Okay, for the main is very simple, but we can copy the code from the GitHub version. Okay, but anyway, we can type it one by one. For example, we define the green LED, the GPIO port with GPIOB. Define GPIO pin GPIO pin 0, and we define the RCC GP green LED clock enable. We tricky do while zero. So we call the how RCC GPIO B clock enable. We need to add the slash to avoid the warning slash new line don't need it this way. Okay, we defined the markers for the LED, green LED. So by the way, we need to include the very top header file stm32h5xx.h. So then we call the how initializations how init. Maybe we need to rebuild to see there is any errors. 2 errors. Okay. Expected identifier or okay. No errors. So let's call the how GPIO init method to see what parameter we needed. So let's specify the green IOD GPIO port, then GPIO init type define needed. So let's go to define GPIO init type define, and then we going to remove the def, then so the mode, let's go to skill and specify the GPIO mode output pp. That pin going to specify green LED GPIO pin. Then we are going to specify the permit. Okay. By the way, before we use any kind of the peripheral, we need to enable the clock for that peripheral. So let's call the clock enable macro. So let's call GPIO tango. So GPIO port, GPIO pin, then we call how delay 250 milliseconds. So let's rebuild the project. Okay, no errors. This is the board. So let's connect a USB cable and then plug in the board with the USB cable. Then we open the options for target, click debug, then select the ST-Link debugger settings. You can see here the debug adapter is detected. So we double check if the reset and run checked. So just click OK. So let's click load to load the code firmware onto the board. Okay, see here. Now the green LED is blinking. So happy coding, happy blink LED. So that's all for today. Thank you guys for your watching. See you next time. Bye bye.